Okay, guys, here we go. So now what we're going to be talking about this time is we're going to be talking about how do we combine like terms. Okay. And you could see that, you're going to be doing a worksheet with this. It's in your packet. So if you wanted to, you could start working on it now to get yourself ahead. Okay. Some of you have experienced what it's like to fall behind. You're going to have a quiz review coming up after this because we just want to make sure that's an essential quiz. And then we're going to have that quiz right away because we want to be able to have this in time for you to be able to work on it and make it up before the winter break. Okay, it's the last essential quiz we'll have, I think. And so with that, we just want to make sure you're ready. Okay. And I think this date is a little bit off. So just don't worry about that date right now. Okay. We'll change that date soon. All right. So now what we're going to be doing is combining like terms. So what we got to do is to discuss what a like term is, right? So if we look at this, we're going to call each one of these a y. We're going to call this triangle. We're using a shape so you can kind of visualize what we're talking about, okay? So if I look, I have 12 shapes here. We're going to call each one of these x's or one of these triangles a y. So just imagine this. There you go. You have 12 y's. Something fits in there, right? And then what we want to do is take 5 y's away. That's what we're doing. We're saying we're going to have 12 y's, and then we're going to take 5 of them away. 1, 2, 3, 4, 5. How many y's do you have left? So this is a really rudimentary way to look at it, but hey, it's what we're doing so you guys can get a glimpse of it. If you look, you can count there are 7 y's left over. Now, here's the thing. How many of you would like to be able to check your answer? What we said is these two are equivalent expressions. Remember what we've talked about, that if we have equivalent expressions, we can check to see if these are equivalent through using substitution. So pick a variable number for y. Now again, let me remind you, 0 and 1, you can use them, but they give false positive results. Sometimes, like if I use 0 for 12y minus 5y, that's going to be 12 times 0 minus 5 times 0 is equal to 7 times 0. And if I was wrong, let's say that I had put down there that this was 6y, right? It's not equal to 6y, but if I put 6y and I put 0 in here, these would all come out. 0 minus 0 does equal 0. Oh, look, I got it right. But you didn't get it right. And so you want to be careful. So I've heard some people say, well, what business do you have telling them which ones they can use? So here's what business I have. I want you to be safe. I want you to make sure you have the right answer. So we're not going to use 0. I'm not going to use 0. I'm going to tell you that if you're intelligent, you're not going to use 0. Okay? Now, if someone says, why can't you use 0? Tell them, gives us false positives. And I always want to be right. So now I'm going to pick another number. So I'm going to pick 2. That's kind of my favorite go-to number because, well, people naturally double things. So I'm going to say, well, let's see if I have 12y, all right, minus 5y. That's supposed to equal, according to my estimate, my work, that's going to equal 7y. These are two equivalent expressions. And so I'm going to check it. I'm going to plug a 2 into here. So a 2 in here and a 2 in here and a 2 in here. You have to put the same number for every y. Okay. So now if I look at this is 24 minus 10. That's going to be 14. And I would draw a line down here. Just get used to drawing that line because you're going to see it later on. And then this 4 times 7, or 7 times 2, that's 14 also. Oh, look, these two are equivalent. So therefore, we just checked to see if these two were right. Guess what? I know now that I have the right answer. Because I said that 12y minus 5y was equal to 7y. That's how many y's I think I have. And then I checked it. I'm going to expect you to do some checking. Okay? When you're doing these assignments, I'm going to expect you to do it and check it. Because when you check it and find your mistake, that's when you're going to learn the most. And so for these first couple of assignments, I expect you to check. Matter of fact, for the next 2 chapters, I expect you to check. Okay? Now let's look at this one. we have 7D plus 4D. Oh, look, we use the same shape. I hope that didn't freak you out. But you could use squares, rectangles. You could use anything you wanted with this. We're going to use some other things in class. We're going to use some tapes to try and get this message across too. But if you look, here's 7Ds plus 4Ds. Well, how many Ds do we have all together there? If you look, you can count 1, 2, 3, 4, but you can also be looking at it and saying, now there's a principle that's going to come out of this that I'm hoping you're going to catch. But hopefully you saw that you have 11 Ds here. So what I want to know is, are these two equivalent? And you may ask, well, Mr. Bruno, why do you want to know these two are equivalent? And I would tell you, because I like to get the answer right. So we're going to plug something in. Again, you could use 0 again, but guess what? It's always going to tell you these. No matter what, you could have said 7D plus 4D is 11D squared. And when you put 0 in there, it's going to come out equal, but they aren't equivalent. Okay? So they aren't equivalent. So 0 gives you a false positive. 1 sometimes gives you a false positive. 2 almost never. So I tend to use 2, but let's use 4. Okay, just for kicks and giggles, let's use 4 to check our solution. Remember, we're trying to see, do we have the right number of D's here? Did we add this all together? Because you don't want to be drawing pictures all the time. We're drawing pictures now so you can get a clue on this. But I'm going to use 4 in place of D. So I'm going to put a 4 in there. Hey, maybe you want to put another number in there. Try 5 or 12 or 350. Go ahead, try that one, but it'll take you a while to do, so I wouldn't do it. So here we go. We got 7 times 4 is 28, and 4 plus times 4 is 16, and 28 plus 16 plus 20 plus 10 is 30, and then 14, so that's going to be 44, right? And again, I'm going to draw this line down here because I'm trying to see, are these things equivalent? And so if I look, 11 times 4, that's 44. Yep, these two are equivalent. So if I put in a 4 for this and I put a 4 in for this and they came out equivalent, then these two expressions must be equivalent. Okay, that's kind of the whole purpose of this lesson today. Can we combine like terms? Because we're saying, oh, look, these are D's. They've all been the same size shapes. So, hey, guess what? We just did that. Okay, let's look at this. This one's a little trickier. Okay, we're going to say these colored ones are the positive B's, and we're going to say the empty ones are the negative B's. Now, we have discussed zero pairs in class a little bit, but just to remember, a zero pair is that if you have a positive one and a negative one, those equal zeros. And we've discussed it a little bit, but if we look, these are all B's, right? So if we look, we have some zero pairs. Here's a zero pair, here's a zero pair, here's a zero pair, here's a zero pair. Those add up to 0. What is left after we do the zero pairs? Well, we have 1, 2, 3, 4, 5, 6, 7, 7 negative B's. So we're going to say this is equal to negative 7B. Negative 7 times B. Okay, so now we want to check, right? Because we want to make sure we're getting the right answer. So, and some of you are starting to see something that's reminiscent from what we were doing a chapter ago, and that maybe you even just saw in another answer. I'm going to give you a hint on the quiz on this, but you probably already figured that out. So here we go. Now we're going to look at this, and we're going to plug in for B. So we're going to plug it in. Let's write out the equation and pick a value, any value, see what you come up with, check and see if these are equivalent. Go. I'm going to pick another value, so you should probably pick your value, see if you get it, or just, if you're not going to try it, then you're not going to figure it out, and then you won't know how to do it. That will be a hard day. Okay, so you should have done this. Okay, so let me drive home a point here. Let's say you did this and you came up with negative 15b. Okay, if we look at the picture, we can see that's not what it is. We have 7 negative b's. But let's just say, okay, let's say you had that. So I'm going to plug this in, negative 15 times b. Now, let's see what happens if you plug in 0. Okay, because some of you are starting to might be saying, hey, my dad said 0 was okay. Why won't, maybe you're offended by 0. And I'm not offended by 0. But let's see what 0 does when you do this. So if I put a 0 in here and a 0 in here and a 0 in here, I'm going to put a 0 in here just to be cool. Okay, if I look, negative 15 times 0 is 0. And 0 times 4 is 0. Minus 11 times 0 is 0. And so I'm just going to draw a line down here because I'm trying to calculate what each one of these is and then checking to see if they're equal. And negative 7 times 0 is 0. So guess what? This says 0. 0 minus 0 is 0. And this one's 0. So in other words, what they just said is these three, if I use this to test my equivalence, I've just said all three of these are equivalent, but they aren't. So that just gave me a false positive. But let me go and check it again. Let's try 2. Here we go. We're going to put a 2 in here now. So if I put a 2 in here, 2 in here, 2 in here, 2 in here. Negative 15 times 2 is negative 30. I want to know, is that equal? 4 times 2 is 8, minus 2 times 11 is 22. And negative 7 times 2 is negative 14. Okay, this side's negative 30. This side's negative 14. One of them is the right one of them is the wrong one. Let's see. 8 minus negative 2. Now remember what I told you to do. Write this out. 8 plus negative 22. Make it into addition. That makes everything a little easier. And so when we do that, we're going to say, and if you have to, look, I told you to write this stuff on everything, right? So if we add a negative, we're going to go that way. So if we're at 8 and we got negative 22, we're going to land at negative 14, which is not equal. It is not equal to negative 30. So these two are not equivalent expressions, but it is equal to negative 14. So these two are negative, or 4b minus 11b does equal negative 7b. Now look, what I'm trying to get you to do is this part right here, right here. That's what you need to know how to do when you come to class. Okay? That's what you're going to learn how to do. The checking, you need to know how to do. But some of you might see a pattern here because you might see that, look, I'm taking 4b plus negative 11b. And some of you might be seeing that, oh, look, there's 4 plus negative 11. You're already doing the math in your head times b. Oh, that gives me, yeah, negative 7. But, that's just for you to see. Okay? And that's how you check to see if things are equivalent. Now, this gets a little harder. Why is this harder? Why would this be harder? Well, there's not everything's the same, right? The picture looks a little different. So I have x's, and then I have 1s. So go ahead and rewrite that. Now what we want to do is we're going to kind of put this together, right? So we're drawing a picture. If I look, what I need to do is put my x's together and my y's together, right? So if I look, I'm going to take these and I'm going to group them together. So what I'm going to do, what property allows me to be able to move things? Commutative property. So what I just did was I said, oh, I'm going to take my x's. Here's my x's. I'm going to put those together. And I'm going to take my numbers and I'm going to put those together. So I'm going to have 12 plus 7 over here. And I'm going to have 7x plus 5x over here. right? I'm using commutative property to put my like terms together. And then when I look, that means all together here, I have 12 x's. And when I add all these together, I have 12 or 19. Okay, that's it. But now I can check, right? Because that's what I said I have. So now I'm going to check it and say, well, if I have 7x plus 12 plus 5x plus 7, is that equal to 12x plus 19? That's my question, right? So I don't know yet, but I think I'm right. So I'm just going to draw my line down here. And now I'm going to check. I'm going to pick a value for x. Maybe I'm going to pick 3 this time. So I'm going to plug that in. Now you check it, see if we got it right. And then come to class ready to tell me if we got it right. When you look at these, we're going to do those next. We'll do those in class to keep things a little safe. Okay? But right now, what I want you to do is check this, see if that's right. It's 16 minutes for the video right now. I'm going to keep us there. Here's the thing you're learning. Here's the so what. We're learning to combine like terms. That when we have them just this way, we could just look at it and say, I have 4 b's and negative 11 b's. When I add those together, I get negative 7 b's. And really, the coolest part of this, and the thing I want you practicing, is you can check your solutions. You could check to see, are these equivalent? And what I'm trying to point out with this here is 0 is a dangerous number to use. Can you use it? Sure. Good luck. But you're going to get some false positives, and false positives lead to mistakes. So it's not the safest number to use. Okay, so here we go. Now look at those. Those are a little scary, aren't they? Here's what I want you to answer. What'd you learn from this video? What questions do you still have? Because those are the important things to bring to class. And what's the hardest part about this lesson? What is the thing you struggle with the most? Circle it, put a question mark next to it, and come to class ready to ask questions. Sure love teaching you guys. You're a great group to be with. Have a good day.